Good morning, friends. This is my next lecture on the GOC, General Organic Chemistry, and today we are going to discuss next point from the GOC. There is the substitution nucleophilic unimolecular reaction. That is the SN1 reaction. Now, before going to deal with SN1 reaction, first we have to know what is meant by substitution reaction. First, we have to know what is meant by substitution reaction. So, substitution reaction is the reaction in which an atom or group of atom or group of atom is substituted by another atom or group of atom, okay, the reaction in which one atom or group of atom is substituted by another atom or group of atom without change in hybridization state, of atom with which that particular substituted atom is directly attached. म्हणजे सबस्टिट्यूशन रिॲक्शन म्हणजे अशी रिॲक्शन की ज्या रिॲक्शनमध्ये एखादा ॲटम किंवा ग्रुप ऑफ ॲटम जो डायरेक्टली एखाद्या ॲटमला अटॅच असणार आहे तो ग्रुप किंवा ॲटम दुसऱ्या ॲटमने किंवा ग्रुपने रिप्लेस व्हायला पाहिजे विदाउट चेंज इन हायब्रिडायझेशन स्टेट of that atom one. So simply same can be explained here. Suppose the reaction is like this. Suppose A dash B is there. Okay, A dash B is there, and suppose it has valences like this, isn't it? Suppose if this atom we want to substitute, then it is replaced by, suppose C is there. Then this C substituted B, and B is removed from its position, and it forms, that is A dash C plus it leaves the B. It leaves B as it is. Simply it is substitution type of the reaction in which one atom or group of atom is replaced by another atom or group of atom without change in hybridization state. Very important. Without change in hybridization state. Now one more point. Nucleophilic substitution reaction means what? Yes, another atom or group of atom which substituted the initial atom or group of atom, that atom or group is of nucleophile. Remember well, the atom which substitutes the other atom or group of atom is the nucleophile one. So it is called nucleophilic substitution reaction. And we have to discuss two types of the nucleophilic substitution reaction, that is the unimolecular and bimolecular. So when it is unimolecular, it is SN1, and when it is bimolecular, it is SN2 reaction. So if you consider the SN1, that is the substitution nucleophilic unimolecular, then in this case first you have to memorize that one reaction must be very important, or you have to memorize that particular reaction. Whenever they ask question on SN1, then in your mind one reaction has to be clicked. That reaction is when tertiary butyl bromide hydrolysis reaction of tertiary butyl bromide, on hydrolysis it gives reaction CH3OH. So tertiary butyl bromide, it gives tertiary butyl alcohol. So this reaction is the general reaction for SN1 reaction. You have to remember this reaction. Now the kinetic data means, here one more word is there extra, unimolecular. What it indicates unimolecular? So actually it is a term related with the chemical kinetics. That is unimolecular reaction, bimolecular reaction, trimolecular reaction, and so on. So unimolecular reactions are the reactions in which there are only one molecule is participated, okay, in slowest step. Bimolecular, 2 molecules are participated. Trimolecular, 3 molecules are participated, and so on, isn't it? So in this case only one molecule is participated. Now see, if you consider the kinetics data of this reaction, study of this reaction indicates that rate of this reaction is directly proportional to concentration of tertiary butyl bromide. So if you kinetics data of this reaction investigation shows that rate of this reaction depends upon the concentration of tertiary butyl bromide one. So as it depends upon concentration of tertiary butyl bromide, in the sense the kinetics also says that the rate expression is always written from slowest step from slowest step of whole mechanism. म्हणजे त्या केमिकल रिॲक्शनमध्ये, त्या स्टेप्समध्ये, त्या मेकॅनिझममध्ये जेवढे स्टेप्स आहेत त्या सगळ्या स्टेपपैकी स्लोवेस्ट स्टेप जी असणार आहे त्या स्लोवेस्ट स्टेपवरूनच काय देतो आपण, रेट लॉ एक्सप्रेशन देतो. ॲक्च्युली इट इज द रेट लॉ एक्सप्रेशन. दॅट इज द रेट लॉ एक्सप्रेशन विच रिलेट्स द रेट विथ द कॉन्सन्ट्रेशन ऑफ द रिॲक्टिंग स्पेसिस, विच रिलेट्स द रेट ऑफ द रिॲक्शन विथ कॉन्सन्ट्रेशन ऑफ रिॲक्टिंग स्पेसिस 1. So slowest step means, in short we say that as it is determined from slowest step, in the sense we can say that in that slowest step only tertiary butyl bromide is participated. Only tertiary butyl bromide is participated, and as in the slowest step only tertiary butyl bromide is participated, therefore overall rate of the reaction is proportional to concentration of tertiary butyl bromide. Means if you increase the concentration of tertiary butyl bromide, rate of the reaction also increases. If you decrease the concentration of tertiary butyl bromide, rate of overall reaction decreases 1. But one more point. Actually, if you consider this reaction, one, then there are two substrates are there, or two reactants are there. One is the tertiary butyl bromide, and second one is the water itself. Isn't it? So, and when we say that, according to chemical kinetics, that is the collision theory, for any reaction, the collision must be takes place between the reactant molecules. जेवढे कोलिजन्स त्या रिॲक्टंट मॉलिक्युल्समध्ये जास्त होतील तेवढं त्या रिॲक्शनचा रेट काय असणार आहे, जास्त असणार आहे. डायरेक्टली प्रपोर्शनल टू रेट ऑफ रिॲक्शन. Collision directly proportional to rate of reaction. As collision increases, rate of reaction increases 1. As collision decreases, overall rate of the reaction decreases 1. Isn't it? So as two reactants are participated, and collision, for to occur collision 1, at least two reactants are required. Okay, then it is what we call as a collision occurs 1. So this, according to this collision concept, two reactants must be present for the collision. But if you observe the rate of the expression, it is directly proportional to tertiary butyl bromide. So if you carefully observe, the water which is present as a second substrate 1 does not participate in the reaction 1. Okay, and as it does not participate in the reaction, then actually product is formed. In that product 1, OH is there. Then from where that OH comes, and as it does not participate in the slowest step, then how this reaction proceeds, same can be explained by a mechanism of this reaction. Same can be explained by considering a mechanism of reaction. Now see, if you consider mechanism-wise this reaction, the reaction that tertiary butyl bromide hydrolysis. Now see, mechanism of reaction, isn't it? Mechanism of reaction. So as reaction, rate of the reaction already we written here, that is the rate of reaction directly proportional to concentration of tertiary butyl bromide. So as it depends upon concentration of tertiary butyl bromide, in the sense in first step, now see here, tertiary butyl bromide is there, and here water is there. Okay, hydrolysis, water is there, H2O, hydrolysis. If you observe carefully substrate, the carbon is in the sp3 hybridization state. Having a pyramidal geometry. Okay, tetrahedral geometry, isn't it? Tetrahedral geometry. Now one more point, that is the carbon is attached with bromine here. So this carbon and bromine, if you consider the electronegativity difference, and due to that electronegativity difference, bromine acquires partial negative charge, carbon acquires partial positive charge. Bromine acquires partial negative charge, carbon acquires partial positive charge. So their polarity is generated in carbon and bromine 1. And solution, actually water is present 1. In solution water is present 1. So if you consider water here like oxygen, hydrogen and hydrogen, oxygen negative charge, hydrogen positive and hydrogen positive. Water is also polar with two poles, one negative and one positive. Oxygen carries minus delta and hydrogen carries plus delta. Now if you observe this one, the carbon is electrophilic center because it has partial positive charge, and water is present surrounding to that substrate 1, it is nucleophilic in nature with respect to oxygen. So there must be attraction. Between the oxygen of water and electrophilic center of carbon 1. But at the same time, attraction is there 1, but at the same time water does not approaches that central partially positively charged carbon. Why? does not approaches, because if you consider the carbon, over that carbon 4 valencies are satisfied by means of 4 bulky groups. Okay, bulky heavy groups are there, 3 methyl groups and 1 bromine group, and all are the bulky group and that's why we can say that the partially positively charged carbon is sterically hindered. It is sterically hindered. Steric hindrance is there. And due to that steric hindrance factor or crowding factor, water does not approaches that carbon 1, up to that carbon 1. It attracted, but no doubt attraction is there one, because it is negatively charged, it is positively charged. Attraction is there one, but does not approaches up to that carbon 1. And during that course, some amount of energy is released. And that released amount of energy is utilized to break the heterolytic friction of carbon-bromine bond. Heterolytic fission between carbon and bromine takes place one, and due to that heterolytic fission between carbon and bromine, it leads in the formation of CH3C, H3C, CH3 plus Br minus. It forms in the carbocation, tertiary carbocation, and one bromide ion. So this must be first step. And as the rate law indicates that, rate is proportional to concentration of tertiary butyl bromide. Rate indicates directly proportional to concentration of tertiary butyl bromide. If you observe carefully this reaction, in this reaction, water or OH minus does not directly participate in the reaction. Just there is a what we call heterolytic fission. Heterolytic fission occurs between the carbon and bromine, results in the formation of carbocation and bromide. So this must be slowest step. And from this slowest step, rate law expression is given. That's why rate of the reaction depends only on the concentration of tertiary butyl bromide. In first step, there is no any role of OH minus. Actually, we don't say like this one, there is no any role of OH minus. Until and unless the OH and there is negatively charged of oxygen and positively charged carbon, there is attraction occurs, there is no cleavage of carbon-bromine bond. But actually, if you increase the concentration of water, it does not affect the overall rate of the reaction. But if you increase the concentration of tertiary butyl bromide, overall rate of the reaction increases. Isn't it? Okay. This is the first step. And in second step, as the carbocation which is formed, if you consider CH3, and H3C, this carbocation formed, and if you consider the carbon, it changes its hybridization state. Here it is sp3 hybridized, in substrate it is sp3 hybridized, but here there is a sp2 hybridized. Hybridization state changes at the same time it becomes planar in nature with 180 bond angle, with 180 degree bond angle, and it's planar in nature. And due to planar nature, the steric hindrance somewhat reduced, or crowding somewhat reduced to some extent one, and easily now water is present. This water easily attacks over this carbocation, positively charged carbon, results in the formation of CH3COH2, H3C, CH3. Actually water is like this, H and H, it is positively charged. Then electron pairs accepted by oxygen, and proton is removed from the system, minus H plus, and overall product formation CH3-C, OH, CH3 and H3C. So this is the tertiary butyl alcohol is formed. So this is the mechanism of the SN1 reaction. Overall mechanism is this one, but for this reaction, rate depends only on the concentration of tertiary butyl bromide. Okay. So this is the mechanism wise we can explain the SN1 reaction. Now if you consider the rate of the reaction, then rate of the reaction depends no doubt only on the tertiary butyl bromide one. But what are the factors? If we change the substrate? Means actually substrate, there are two parts. In the substrate. One part of substrate, that is R-X. Two parts of substrate. One part is the alkyl group, second part is the halogen, or halogen is there. Okay. So substrate means if we change the what we call as alkyl group, means if we change the substituent present on alkyl, if we change the halogens, okay, means chlorine, bromine, iodine. If we change the solvent, then how it affects the overall what we call the rate of the reaction can be explained now. That is the factors that affects the rate of reaction. Now see, if you consider the first substrate, means by changing the substrate structure, substrate. Actually in substrate R dash X, first we going to change the alkyl part. Now see here, the first H3C, C, CH3 bromine, then CH3 CH, CH3 bromine, CH3 CH2 bromine, and CH3 Br. Okay, now if you consider this is simply methyl bromide, this is ethyl bromide, isopropyl bromide, and tertiary butyl bromide. Now if you consider the sequence, actually we from first, second, third, and fourth, if you consider first to fourth, actually we decreases the steric hindrance factor or crowding factor from first to fourth one, means from left to right one, isn't it? Now actually in first case the steric factor is more in case of carbon, but in fourth case the steric factor is very much less. Okay, much less. Actually it decreases one. Then in which case the SN1 reaction is more easily occurs or faster and slower, and we are going to discuss now. See, now if you consider in all these cases, just I told already that whenever they ask to, that is the rate of SN1 reaction, then we have to consider we have to give the preference to steric factor. And as steric factor, more the rate of SN1 reaction. Steric factor is very important. Now see, if you consider the carbon is sterically hindered by means of 3 methyl group. Here 2 methyl group. Here only 1 methyl group, and here only hydrogens are there. So steric factor is more in case, least and very much less is there. So that's why the rate of SN1 reaction for this substrate is like this one. Order of SN1 reaction for this substrate is like this one, because steric factor is more here. Okay. If you consider like this one, okay, you may consider. Now one more point. Don't consider that the rate of SN1 reaction is directly proportional to carbocation stability. Carbocation ची स्टॅबिलिटी जितकी जास्त, तेवढा SN1 चा रेट जास्त. Almost in all cases it is possible. Means if you consider substrate, remove the leaving group first. Okay, after leaving group is removed, positive charge is formed. In this case positive charge is formed as this carbon plus. In this case positive charge is formed on this plus. Here positive charge is formed, and here simply positive charge is formed. Now in all cases, if you consider the stability of carbocation, same order is the stability of carbocation, because it is stabilized by means of 3 inductive effect plus 9 hyperconjugated structure. Here it is stabilized by 2 inductive effect, 6 hyperconjugated structure. It is stabilized by 1 inductive effect, 3 hyperconjugated structure, and no stability. So order is same one. But if you consider the structure of allyl bromide, okay, and if you consider the tertiary butyl bromide, जर consider केलं तर tertiary butyl bromide आणि allyl bromide मध्ये जर comparison केलं, if you remove the bromine from this, one, then it becomes resonance stabilized like this one. It is positive charge. If you consider this tertiary butyl bromide and this allyl carbocation and tertiary butyl carbocation, okay, it is stabilized by means of resonance. And as it is stabilized by resonance, resonance is always more dominant over inductive effect and hyperconjugation. So that's why this carbocation is more stable as compared with tertiary butyl bromide one. And therefore rate of SN1 reaction must be faster. In this case, according to your theory, if we assume that stable carbocation, more the more will be the rate of SN1 reaction. If we assume that one, then in this case this must undergoes more easily SN1 reaction in comparison with this one. But it's not possible. Why? Because if you observe this one, here actually 2 hydrogen atoms are there. One. Now if you observe this carbon, it is positively charged bromine. Okay, bromine attracts the electron pair, and at the same time, it is this carbon. If you observe, it is in the sp2 hybridized state, and this carbon is in the sp3 hybridized state. 3 hybridized state 1. That's why sp2 hybridized is more electronegative as compared with sp3. Electronegativity, sp is more than sp2 than sp3. So due to which it withdraws the electron pair also. At the same time, before leaving the bromine, just observe the substrate, it withdraws the electron pair 1. That's why this carbon becomes more and more positively charged, and therefore nucleophile which is present, nucleophile present here, okay, nucleophile present as a water, it attacks easily over this positively charged carbon, positively charged carbon 1, because the steric factor is very less here, because the steric factor is hydrogen atoms are only there, so steric factor is very less 1. So as steric factor is less 1, so water easily attacks on this carbon. At the same time, it removes the bromine from the system, and it proceeds through SN2 reaction. Therefore, SN1 rate is small, or what we call it, the rate of the reaction is less, but here SN1 is more. SN1 is here, means 100%. If you observe this one, there is no any chances of SN2 reaction. But here there is a possibility of SN2 also, SN1 also. But comparative study, the SN1 is more in this case, SN1 is less in this case. Okay, so don't consider that कार्बोकॅटायन, स्टेबल कार्बोकॅटायन जो स्ट्रक्चर देतो त्याचा रेट ऑफ रिॲक्शन फास्ट असतो टुवर्ड्स SN1 रिॲक्शन. इट इज नॉट. ऑब्झर्व सबस्ट्रेट अँड स्टेरिक फॅक्टर. Okay, so this is the substrate. Now if you consider another part of substrate, it is a halogen. Now see, if you consider the suppose CH3 alkyl part, if I kept constant, alkyl part जर कॉन्स्टंट असेल आणि समजा फ्लोरीन एकदा घेतला, ब्रोमीन एकदा घेतला आणि आयोडीन एकदा घेतला, ठीक आहे, टर्शियरी बिटवीन फ्लोराइड, क्लोराइड, ब्रोमाइड अँड आयोडाइड वन. देन in this case if you observe these halogens, one iodide is better leaving group, one. So when iodine is present, it what we call as a rate of reaction increases, one, than bromine, than chlorine, and then case of fluorine. So this is the decreasing order of the leaving group, of the better leaving group, actually enhance the rate of SN1 reaction, isn't it? Enhance the rate of SN1 reaction. Now one more point, that is the second point, that is the nucleophile. Rather than nucleophile, that is the reagent. Actually in SN1 reaction, the role of reagent is played by same, that is solvent, also acts as a reagent one. Now if you observe the SN1 reaction, solvent used is weak polar protic solvent. Weak polar protic solvent is used, like water, methyl alcohol, or ethyl alcohol. Why weak protic solvent is used here for SN1 reaction? If you observe the first step of the SN1 reaction, in first step what happens? CH3 and it is Br. And here heterolytic fission takes place. Due to that one, yes, bromine removes from the system and it becomes CH3 carbocation plus Br minus. So in first step, there is the heterolytic cleavage of substrate takes place. Carbon bromine results in the formation of carbocation and bromide ion one. Okay. If weak polar protic solvent is used, what is the role of polar protic solvent here? So solvation is very important here. This solvation provides the stability. One. Okay. What happens? Water is there one. Water is there solvent. Water oxygen end, it is plus charge one. So oxygen end of water provides the stability to this positively charged carbon, and plus end of water, that is hydrogen, provides the stability to Br minus, because it is plus delta, it is minus, it is plus, it is minus one. Due to that solvation one, it provides the stability to what we call as a substrate one. And one more, that is also recombination. Also is inhibited because of recombination, plus and minus. So again there is a recombination and reversible reaction may possible. So again that will be also hindered to some extent. That's why polar protic solvent is used. And here weak is very important. Weak solvent is there one. Not necessary to use strong solvent one. Isn't it? Because in this case solvent which we are using, that is the nucleophile which we are using, this nucleophile, even it is weak, it is very it may what we call it as proceeds the reaction one. How? Because it does not affect directly on substrate one. It waits till the substrate it heterolytically cleavage takes place to form carbocation and bromide one. And once the carbocation is formed, due to positive charge, this nucleophile easily attacks on the carbocation to give final product. So that's why weak polar protic solvent is used like water, methyl alcohol or methyl alcohol, isn't it? Methanol. So this is overall about the what we call as factors that affects the rate of the SN1 reaction. Now one more point, that is the last point of this, that is the we have to consider the stereochemistry of SN1 reaction. Stereochemistry. As far as stereochemistry is concerned, so stereochemistry means we have to, whenever stereochemistry, we speak about stereochemistry, we have to click that the chiral carbon atom, that is the carbon which is attached with four different groups or atoms on. Means 4 valences of carbons are satisfied by 4 different atoms or groups on. Okay, 4 different atoms or groups on. Now for the purpose, if I take an example, suppose like this, carbon is there, CH3 is there, okay, here bromine is there, CT3 is there, and CD3 is there. Okay, so this is the chiral carbon atom. Carbon is central and it is satisfied by means of 4 different atoms or group: methyl, bromine, CT3 and CD3. Actually deuterium and tritium. Is there. Okay, deuterium and tritium is there. Now if you observe the stereochemistry of this compound, carbon stereochemistry, if we speak the stereochemistry, this will be number 1. Okay, this will be number 2, and this will be number 3, and methyl is at the back side. जर आपण कन्सिडर केलं तर या केसमध्ये जी स्टिरियोकेमिस्ट्री येणार आहे, इट इज 1, 2 and 3. इट इज राईट हँड साईड, लेफ्ट हँड साईड. इट इज अँटी क्लॉकवाइज डायरेक्शन. Clockwise direction, and as it is clockwise direction, it is R configuration. Its configuration is R. Okay. Now if bromine is removed from the system, heterolytic cleavage, bromine is removed from the system. When bromine is removed, the structure becomes CH3C, it becomes CT3, and becomes D3C, CD3. It is positively charged carbocation is formed. Okay. Now the carbocation which is formed here, it is planar in nature. And due to planarity, if you consider this carbocation is present, then on this carbocation, carbon is present here, 1 methyl group, 1 CD3 and 1 CT3 is there. So the positive charge carbon nucleophile may attacks from above the carbocation, also it attacks the below the plane. Means above the plane and below the plane. Means there is a 2 possibility of attack. That is a from front side as well as from back side attack possible one. So if you consider, if OH minus, that is the nucleophile, and here one OH minus, that is the nucleophile, if it attacks from this position and if it attacks from this position, when it attacks from this position, the structure becomes carbon, methyl is there, and here yes OH, or you may write like this, OH, CT3, D3C, this structure. And if you observe the what we call as one more, that is the first step, and second step, if it attacks from other side below the plane, then structure formed is like this: methyl, carbon, it attacks D3C, it becomes HO, and like this CT3. Now see here, if you consider the, it is R configuration. Now here if you consider, it is 1, 2 and 3, then this structure becomes, yes, it is again R configuration. And if you consider in this case, it is number 1, 2 and 3. If you rotate this one, it is S configuration. So if initial chirality is present in the substrate 1, due to formation of planar carbocation, planar sp2 hybridized carbocation 1, attack of nucleophile is possible from both the side, above the plane, below the plane. That's why two what we call as a stereo isomers are formed. One, that is one with R configuration, second one with S configuration, second one with S configuration, second one is with S configuration. Actually these two are the mirror images of each other. They are called as stereo isomers or enantiomers. They are called as an enantiomers. Okay. Now one more point. Actually when the backside attack possible, when the backside attack is possible, due to backside attack one, there is a inversion takes place one. Actually not here backside and front side. Okay. So whatever configuration, initial configuration, okay, suppose here in this case initial configuration of substrate is R, and due to attack of nucleophile, if the configuration of substrate remains same, R is the remains R, and if the configuration changes from R to S, then in this case 50% of R configuration and 50% of S configuration is expected, because carbocation is planar. So if R remains R, this is called as retention of configuration. It is called retention of configuration. And if R is there initial, but it changes S, or if S initial changes to R, it is called as an inversion of configuration. It is called inversion of configuration. Actually, it must be what it called racemic mixture is formed. Racemization is there one. One of the most important characteristic feature of SN1 reaction, that is the final product is always racemization. Racemic mixture is formed. But if you observe the amount with respect to amount one, that is the inversion product is always more as compared with that of the retention product. Inversion product is always more as compared with retention product. Why? Inversion product is more as compared with retention product. Now if you consider the carbocation, okay, if you consider the carbocation, suppose I would like to say the structure of carbocation here like this. Just consider structure of carbocation. Okay, here one more here, suppose like this structure is there. Just imagine here the suppose brown colored, here sketch pen is there, brown colored. If this brown colored what we call as bond is suppose like it is bromine, it is leaved from the system, to form stable carbocation. It forms stable carbocation. But when it leaves from the system, Br minus, it present over that carbocation somewhere in the solution. And here positively charged carbon is formed. So nucleophile which is present, the attack of nucleophile may possible from this side also and from back side also, isn't it? But nucleophile is also negatively charged, and the Br minus, which is initially what we call as separated from that substrate, is present somewhere in vicinity to the carbocation one, isn't it? Therefore nucleophile prefer to attack the carbocation from the backside, because here somewhere there is a Br minus is present, isn't it? And the nucleophile is also negatively charged. Therefore attack from this side is what we call as a less extent, but attack from this side is more extent. That's why inversion is more what we call as dominant product than retention. So if you speak about the amount, inversion product is always more as compared to the retention, So this is overall about the SN1 reaction. And in next lecture we are going to discuss the SN2 reaction. It is the substitution nucleophilic biomolecules. Okay, good day.